Welcome back to Yale STEM Baddies. Before we dive into today's lesson, I wanted to introduce this summer's raffle prizes. You can sign up for our raffle by subscribing to this YouTube channel and by sending an email to Yale STEM Baddies at gmail.com. So once you do those two things, you are eligible to win one of our fun raffle prizes this summer. This summer, we are raffling off free study guides for calculus. This can be used for, high school or college level calculus courses. And then I'm also raffling off a Zoom date with one of my Yale STEM friends, Max. So definitely enter to win. He's one of the biggest STEM baddies I know. So definitely want to look into that Zoom date. So remember to subscribe and send an email to enter our raffle. Today's video is going to be about Gaussian elimination. So we're going to use Gaussian elimination to solve this system of linear equations. So the first thing I want to do is put this system into a matrix form. So let's go ahead and write our coefficients here. And I see 1. I'm just writing our coefficients. So I see here 0, 4, 1. I see 1, 2, 1. And then I see 3, 8, 1. Then let's put in our variables here. And then let's put in our, result vector. So this is 2, 2, 12. Okay, perfect. So let's go ahead and think about how we are going to go about solving this equation using Gaussian elimination. So let's go ahead and actually just, the variables are just sort of superfluous to us. We don't care about those variables. We don't want to have to keep writing them. So let's just go ahead and put this into one of these things that we call an augmented matrix. So this is just a matrix that excludes the variables because we don't want to have to keep writing them. We can memorize X, Y, and Z. That's not really important. So we have this augmented matrix. And now let's go ahead and use our row operations to put this into reduced row echelon form and find our solution. So remember that in Gaussian elimination, we can apply the following row operations. We can swap 2 rows. Remember, we can multiply a row by a non-zero scalar. And then we can also, add rows or add scaled rows together. Those are the 3 operations we can do without changing the equation's solution set. So let's go ahead and apply these operations to this. Let's just apply these operations to this augmented matrix here. So we got, I didn't copy the whole thing. Sorry, I think that's right. So the first thing I want to focus on is, my first goal is to look in the upper left corner of this matrix. Look at that entry right there. And I want that to be a 1. And normally, if it was just a number that's not a 1, like 4 or 5, I could, multiply that by, 1/4 or 1/5, multiply that whole row by 1/4 or 1/5 to get that first entry to be 1. But there's actually nothing I can multiply 0 by to get that to be 1. So instead, I'm going to use my first row operation. I'm going to swap 2 rows. So I'm actually going to go ahead and swap rows 1 and 2. So let's just go ahead and do that. That's super easy. We're swapping the first and second rows, and now perfect. I have a 1 in that upper left corner. Okay, perfect. So now I want to use this 1 and add multiples of the top row to the rows below it. So I zero out every entry below that upper left 1. Well, lucky for us, this is already a 0. So that step's already taken care of. So now I want to I want to get rid of this entry right here, this 3, turn it into a 0. Sorry, let me draw that better. So let's go ahead and multiply the top row by -3. So that's going to give us -3, -6, -3, -6. And then we're going to add that row to the scaled row to this bottom row here. So let's go ahead and do that. So that's gonna give us the result of, these rows remain unchanged. 2, perfect. And then this bottom row is going to become -3 plus 3, that's 0, -6 plus 8 is 2, -3 plus 1 is -2, and then -6 plus 12 is 6. Okay, perfect. So now this row is perfect. Or column is perfect. We got 1 followed by zeros below it. Okay, perfect. So now let's go ahead and look at the entry in the the network. Let's go over a row and or over a column, down a row. So boom, boom. Oh, now we're at this entry. So now our goal is to make this entry a 1 as well. So we want to make that a 1. What can we multiply that by to make it a 1? Well, let's multiply that whole row by 1/4. We'll scale that whole row by 1/4. So what does that leave us with? 0, 1, 1/4, and 1/2. Okay, perfect. So, and then this row is unchanged on the bottom here. Okay, perfect. So now we have a 1 here, and now we want to add scalar multiples of that middle row to the rows below it so that we zero out everything below that 1. So what do we have to do to zero out everything below that 1 in the middle column? Well, let's scale this row by -2. Sorry, my colors weren't working. We want to multiply this by -2 so that when we add it to the bottom row, it zeroes out that 2 right here. So if we multiply that row by -2, we get 0, -2, -2 times is -1/2, and then finally we're going to be left with -1 there. Now we're going to add that scaled row to the bottom row, and we're going to get 0 plus 0 is 0, -2 plus 2 is 0, -1/2 plus -2, I believe that's -5/2 if I commonize those denominators, and then -1 plus 6 is 5. Okay, perfect. And now, so now we've successfully handled this column. We've zeroed out everything below that 1. And now let's go, over a column, down a row to this entry here. -5/2. We want that to be a 1. And what can we scale that row by so that this becomes a 1? Well, sorry. Let's try to highlight that. Well, we can make that we can multiply that by its reciprocal. So let's go ahead and just multiply that bottom row or scale it by -2/5. So that's going to leave us with these rows untouched here. And then this bottom row is 0, 0, 1. And then what is -2/5 times 5? Oh, well, that's just going to be, very conveniently, -2. Okay, perfect. So this is what's called row echelon form. But this is not our final answer. This is not our final solution to the problem. We're not done yet because we still have not zeroed out these numbers. So row echelon form is, there's sort of a complex definition for it, which we won't get into. But it, intuitively, it just means that we've sort of done half of the zeroing out, right? We've zeroed out all this stuff and we've put 1s here. And maybe it's not even important in row echelon form to have strictly 1s there. But we've zeroed out pretty much this lower left side of the matrix. But now to find the total, the final solution to this system of equations, we want to put it into reduced row echelon form, which is going to be zeroing that upper right part of the matrix out. So now we're going to have to work from the bottom up So I'm going to start in this lower right corner, and I'm going to use that 1 to zero out everything above it. We're going to add scalar multiples of this row to everything above it. So let's go ahead. What can I, multiply that bottom row by so that when I add it to the middle row, it gets rid of this 1/4? Well, I'm going to multiply this bottom row by negative 1/4, right? And that's going to give us 0, 0, negative 1/4. And I think this is going to be negative 1/4 times negative 2 is positive 1/2. Okay, that's nice. And then let's add this scaled row to that middle row. So what's that going to give us? 1, 2, 1, 2. So that's 0 plus 0 is 0. 0 plus 1 is 1. Negative 1/4 plus 1/4 is 0. 1/2 plus 1/2 is 1. Very nice. And then let's go ahead here, and then let's keep this bottom row. Okay, perfect. So now what can I then add this? What can I multiply this 1 by to zero out this 1 above it? Well, let's just multiply that by negative 1. So let's go ahead and multiply this, or scale this bottom row by negative 1. So that's going to give us 0, 0, negative 1, positive 2. And then we add that scaled row to that top row. So 0 plus 1 is 1. 0 plus 2 is 2. Negative 1 plus 1 is 0. Perfect. 2 plus 2, that's going to give me 4. Okay, perfect. All right. And now our last step to put this into reduced row echelon form is we want to use this middle one to zero out everything above it. So we now want to zero out this 2. So that's looking pretty much to me like we want to multiply this middle row, or scale it, by negative 2. And if we do that, that gives us 0, negative 2, 0, negative 2. And then if we add that scaled row to this top row, it looks like we're going to get 0 plus 1 is 1, negative 2 plus 2 is 0, negative 2 plus 2 is 0, 0 plus 0 is 0, and then negative 2 plus 4 is 2. Perfect. Now we just write these lower rows as they were. And perfect. Now if we put this back into, matrix, full formal matrix form, we'll see that we now have, we basically just have the identity matrix over here, right? This is the identity matrix. So that means that when we multiply that matrix by x, y, and z, it's just going to give us x, y, and z back. The identity times anything is that thing. So all this equation is telling us is that x, y, z equals 2, 1, negative 2. So our final answer is that x equals 2, y equals 1, and z equals negative 2. So, as you see, the reduced row echelon form gave us the final answer over here. And that is how you use Gaussian elimination to solve these types of linear equations.